A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
Hey everyone! Welcome back to My Weird Prompts. I am Korn, and I am sitting here in our living room in Jerusalem with my brother Herman.
Herman Poppleberry at your service. It is a beautiful day outside. The sun is hitting the stone walls just right, but we're going to spend it talking about something that lives in the dark, damp corners of your source code.
Right, and this is a topic that our housemate Daniel brought up recently while he was working on a new project. He was asking about the best way to move away from those messy local configuration files and into something more professional. It got us thinking about how many developers are essentially leaving their front door wide open while thinking they have a high-tech security system.
It is the classic false sense of security, corn. We often talk about artificial intelligence and high-level architecture on this show, but today we are getting into the plumbing. We are talking about secrets management. And when I say secrets, I am not talking about your middle school crush. I'm talking about application programming interface keys, database credentials, and those cryptographically signed tokens that literally hold the keys to your digital kingdom.
It is a massive problem, and the scale is honestly hard to wrap your head around. I was looking at the data from the GitHub 24 security report, and they reported that 39 million secrets were leaked that year. 39 million. That is not just a few people forgetting to add a file to their ignore list. That is a systemic failure in how we handle sensitive information in the development workflow.
And the scary part, which we really need to emphasize for everyone listening, is that it is not just about the leak itself. It is about the speed of exploitation. If you commit a secret to a public repository today, it is not sitting there waiting for a human to find it. Automated bots are crawling the GitHub firehose in real time. They are harvesting those credentials within seconds or minutes. You can have an unauthorized actor running crypto mining scripts on your Amazon Web Services account or exfiltrating your entire customer database before your build process even finishes.
That is the urgency we want to convey today. We are going to move through what we call the maturity progression of secrets. We'll go from the insecure legacy traps like .env files, through password managers, and finally into dedicated secrets, management, and zero-trust infrastructure.
I love that framing, because most people start at the same place. They start with hard-coded strings. They're just trying to get the code to work, right? You put the key right there in the variable. Then you realize that is bad, so you move to a .env file. You think, okay, I put this in my .gitignore file, so it is not in the repository. I am safe. But corn, as you and I have discussed many times, that is a very fragile line of defense. It is what I call security by pinky promise.
It really is. The .env file is the legacy trap. It feels secure because it is local, but it creates this massive friction point the second you bring in a teammate. How do you share that file? Do you send it over Slack? Do you email it? Now your secret is sitting in the chat history of a third-party application. Or even worse, someone forgets to update their .gitignore on a new machine, and suddenly that file is part of the permanent immutable history of the Git repository.
Before we go further, we should probably define what we mean by the secret's lifecycle. Because a secret is not just a static thing, it has a journey. It starts with creation, where the key is generated. Then there is injection, how that key actually gets into your running code. Then there is rotation, changing that key periodically to limit the damage if it is leaked. And finally, revocation, killing the key when it is no longer needed or if a team member leaves.
Most developers only think about the first two, creation and injection. They generate a key, they stick it in a file, and they forget about it. But the real security happens in the last two, rotation and revocation. If you cannot rotate your keys easily, You do not actually have a security system. You just have a very expensive lock that you can never change.
And that is why the standard developer workflow is inherently insecure. It is built for convenience, not for the lifecycle. When you use a .env file, you are essentially saying, I am going to trust every single person who has access to this machine, and I am going to trust that this file never, ever leaves this folder. That is a lot of trust for a professional environment.
So, Herman, let's look at the next step in that progression. A lot of teams say, okay, we will put our secrets in a password manager, something like 1Password or Bitwarden. It is encrypted, it is shared, and it has an audit trail. That seems like a huge step up, right?
It is a step up for humans, but it is not necessarily a step up for the machines. This is where the functional gap between a generic password manager and a dedicated secrets manager becomes clear. A password manager is a box for keys. You have to go to the box, take the key out, and manually put it where it needs to go. That usually means a developer is still copying and pasting secrets into a local file on their machine so the application can read them. You are back to the .env problem, just with a more secure source.
Right, so the secret still ends up living on the disk in plain text at some point. That is what we want to avoid. If a laptop is stolen or a local process is compromised, that plain text file is sitting there like a gift for an attacker.
Precisely. This is why dedicated tools like Doppler or infizz ihcool or the secrets automation features in 1Password are so powerful. They introduce a mechanism called command line interface injection. Instead of the application reading a file from the hard drive, the secrets manager injects those variables directly into the process memory at runtime.
Explain that a bit more for the non-security experts listening. What does that actually look like for a developer on a Tuesday afternoon?
Great question. Instead of running a command like npm start, the developer might run a command like Doppler run followed by double dashes and then npm start. What happens is that the Doppler tool authenticates with the cloud, fetches the latest secrets for that specific environment, and feeds them directly to the node process as environment variables. The secrets never touch the disk. They exist only in the volatile memory of that specific process. If someone steals that developer's laptop while it is turned off, there is no .env file for them to find.
That is a fundamental shift. It moves the secret from being a static asset on a hard drive to being a dynamic piece of data that only exists when it is needed. And it also solves the versioning problem. If you need to rotate a key because you think it was compromised, you change it in the central manager, and every developer on the team gets the new key the next time they start their application. There is no more hunting down everyone on the team to tell them to update their local files.
And that leads us perfectly into the concept of environment scoping, which is a huge part of the principle of least privilege. In a professional setup, you have different environments, development, staging, and production. A junior developer working on a new feature should probably have the keys to the development database, but they absolutely should not have the keys to the production database where the real customer data lives.
This is where the old way of doing things really falls apart. If everyone is sharing a big list of secrets, everyone has access to everything. This is what we call secret sprawl. It is like having one master key that opens every door in the building, and then giving a copy of that key to the intern, the delivery driver, and the janitor.
With a dedicated secrets manager, you can implement role-based access control. You can say that only the lead engineer or the deployment pipeline has access to the production environment. Everyone else stays in the sandbox. This is cryptographically isolated. Even if a developer tried to fetch the production keys, the system would reject the request because their identity is not authorized for that scope.
It is about reducing the blast radius. If one developer's credentials are compromised, the attacker only gets access to the development environment. It is a headache, but it is not a company-ending event. If you have production keys floating around on every laptop in the office, your blast radius is the size of the whole company.
I think it is important to mention that this applies to our work with artificial intelligence as well. We talked about this back in episode 1070 when we were looking at the agentic secret gap. As we start using more autonomous agents to help us write and deploy code, those agents need application programming interface keys to function. If we are not careful, we are giving an artificial intelligence agent full access to our entire infrastructure.
That is a great callback, Korn. Those agents are essentially just another type of developer on the team. They need to follow the same rules of least privilege. You do not give an agent your master Amazon Web Services key. You give it a scoped key that can only do exactly what it needs to do for that specific task. If the agent is just supposed to read from an S3 bucket, it should not have the permission to delete the entire database.
So, let's talk about the next level of maturity, which is where things get really interesting. We have talked about storing secrets securely and injecting them into memory, but what if the secrets were not even permanent? What if they only existed for an hour?
Now we are talking about dynamic secrets. This is something that enterprise-grade tools like HashiCorp Vault are famous for. Instead of storing a static username and password for a database, the secrets manager actually has the authority to create a temporary user on that database. When your application asks for a credential, Vault goes to the database, creates a new user with a random password, gives it a 1-hour lifespan, and hands those credentials to the application.
And then, after an hour, the database automatically deletes that user. It is like a valet key for your data. Even if an attacker manages to scrape that secret from the memory of your running application, it is useless to them by the time they try to use it. This completely eliminates the need for manual secret rotation. The system is rotating the secrets every single hour, or even every single minute, automatically.
That feels like the ultimate goal for any security-conscious team. It removes the human element from the rotation process, which is usually where things break. Someone forgets to update a key, or they update it in one place but not the other, and suddenly production is down because the database rejected the old password.
It is a beautiful system when it works, but I want to pivot a bit to the continuous integration and continuous delivery pipelines because that is another place where secrets often go to die. We have seen some high-profile incidents recently where pipeline secrets were leaked.
You are thinking of the incident from early 25, right? The TJ Actions change files incident.
Yes, exactly. For those who missed it, that was a case where a very popular GitHub action had a vulnerability that could allow an attacker to exfiltrate secrets from the pipeline. The problem is that many developers assume that if a secret is marked as a secret in GitHub, it is perfectly safe. But if your build script prints out environment variables for debugging purposes, or if a malicious dependency is added to your project, those secrets can be printed right into the public build logs.
This is the log leak trap. Most modern platforms try to mask secrets in the logs. They see a string that matches a known secret and they replace it with asterisks, but that is not a perfect system. If the secret is encoded in base 64, or if it is part of a larger string, or if it is just a short string that the masker misses, those secrets can end up in a public log that is archived forever.
And that is why we advocate for tools that scan for secrets before they even leave your machine. This is a huge takeaway for our listeners. If you are not using pre-commit hooks, you are playing with fire.
Let's break that down. A pre-commit hook is basically a script that runs every time you type git commit. Tools like ggshield or detect secrets will look through the code you are about to commit. They use regular expressions and entropy checks to find things that look like an Amazon Web Services key or a private encryption key. If they find something suspicious, they will stop the commit and warn you.
It is a safety net. It is not perfect, but it catches the most common mistakes. I think every developer, even if they are working solo, should have these tools installed. It is just basic hygiene. It is like washing your hands before you cook. You might not get sick every time you skip it, but why take the risk?
I like that analogy. It really is about establishing these habits early, because as your project grows, and you add a second developer, and then a fifth, and then a 10th, the complexity of managing these secrets grows exponentially. If you start with a solid foundation of using a secrets manager and pre-commit hooks, you are saving yourself hundreds of hours of remediation work down the road.
And let's talk about offboarding for a second. This is a huge pain point for teams. When a developer leaves the company, how do you know which secrets they had access to? If you are using .env files, the answer is probably all of them. And that means you have to rotate every single key in the company the day they leave.
That is a nightmare. But with a dedicated secrets manager, you just revoke their identity in the central system. Boom. Their access to the development, staging, and production environments is gone instantly. You still want to rotate your keys eventually, but the immediate threat is neutralized with one click.
It is about moving from a reactive posture to a proactive one. So, Corn, if you were talking to a developer who is currently using a .env file and wants to level up today, what are the first 3 things they should do?
First, I would say audit your Git history right now. Use a tool like GG Shield to scan your entire repository history. If you find a secret that was committed 3 years ago, assume it is compromised and rotate it immediately. Do not just delete the file, change the key at the source.
That is critical. A secret in the history is a secret in the wild, and remember, Git is immutable by default. To truly get rid of it, you have to use tools like Git filter repo or the BFG repo cleaner to rewrite your entire history. It is a painful process, but it is necessary if you have leaked something sensitive.
Second, choose a dedicated secrets manager. You do not have to go straight to HashiCorp Vault if you are a small team. Tools like Doppler or lifecycle are incredibly easy to set up. They have free tiers for small projects, and they will get you into the habit of using command line interface injection instead of local files.
And the third?
The third is to implement those pre-commit hooks we mentioned. Make it impossible for yourself to make a mistake. Automate your security so you do not have to rely on your memory or your attention span after a long day of coding.
I would add a fourth one to that list, which is the principle of least privilege. Even if it is just you and one other person, create separate environments. Have a development environment and a production environment. Use different keys for each. It forces you to think about where your data is going and who has access to it.
That is a great point. It is a mindset shift. You have to stop thinking about security as a hurdle that slows you down and start thinking about it as the foundation that allows you to move fast with confidence. If you know your secrets are managed and your environments are isolated, you can deploy on a Friday afternoon without having a panic attack.
Well, maybe not every Friday afternoon. Some things are still sacred, but you are right, it takes the edge off.
I think it is also worth mentioning that we are seeing a shift toward what is called zero trust infrastructure. This is the idea that no part of your system should automatically trust any other part. Just because a request is coming from inside your network does not mean it is legitimate. In a zero-trust world, every single interaction requires a fresh, short-lived credential.
That is where the industry is heading. We are moving away from the idea of a hard perimeter like a castle with a moat, and toward a world where every single room inside the castle has its own lock and key, and those keys expire every 10 minutes. It sounds complicated, but with the right tooling, it actually becomes invisible to the developer.
It is about moving the complexity into the platform so the human can focus on solving problems. That is really the theme of a lot of our discussions here on My Weird Prompts. Whether we are talking about artificial intelligence or secrets management, we are looking for ways to use technology to protect us from our own human fallibility.
And speaking of human fallibility, we should probably wrap this up before I start talking about the mathematics of elliptic curve cryptography for the next 3 hours.
Save that for the next episode, Herman. I think we have given people a lot to chew on here. The transition from local files to robust secrets management is one of the most important steps a developer can take as they grow in their career. It is the difference between being an amateur and being a professional.
And if you enjoyed this deep dive, you should definitely check out some of our past episodes. We mentioned episode 1070 on the agentic secret gap, but episode 1217 on protecting system instructions for artificial intelligence is also very relevant. It is the same principle of protecting the hidden logic and credentials that make your systems work.
We also have episode 677, where we talked about the legal and security implications of open source licenses, which touches on some of the supply chain issues we mentioned today. You can find all of those and more at myweirdprompts.com.
And if you are finding value in these conversations, we would really appreciate it if you could leave us a review on your favorite podcast app. Whether it is Spotify or Apple Podcasts, those reviews really help other developers find the show. We see every single one of them, and we really appreciate the feedback.
We do! And if you want to stay up to date with new episodes, the best way is to join our Telegram channel. Just search for My Weird Prompts on Telegram. We post every time a new episode drops, and it is a great way to make sure you never miss a deep dive.
You can also find our RSS feed on the website if you prefer the old school way of subscribing. We are all about options here.
All right, I think that is a wrap for today. Thanks to Daniel for sending in the prompt that sparked this whole discussion. It is a topic that does not get enough attention, but it is absolutely vital for anyone building software in 26.
Stay secure out there, everyone. Do not commit your secrets, and do not trust your .gitignore file more than you trust your own mother.
That is a high bar, Herman. Thanks for listening to my weird prompts. We will see you in the next one.
Goodbye, everyone.
Talk to you soon.
So, Korn, do you think we should actually go and check Daniel's repositories now? Just to make sure he took his own advice?
I think that is a great idea. I will grab the scanner. You grab the coffee.
Deal. See you in the terminal.
This has been my weird prompts. Thank you for spending your time with the Bubbleberry Brothers. We know there are a lot of podcasts out there, and we are glad you chose to go deep with us today.
Until next time, keep your keys close and your secrets closer. Or better yet, do not keep them at all. Let a manager do it for you.
Catch you later.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts.